We're going to calculate the length of a line segment, which is the same as finding the distance between 2 points. To do so, we're going to use Pythagoras' theorem, which is based on the lengths of the sides of a right-angled triangle. In this right-angled triangle, we have labelled our hypotenuse, our longest side, as C. And this side squared is equal to the two shorter sides squared and then added together. We can use Pythagoras' theorem either algebraically or in a more visual and numerical approach. First, the algebraic method. Let's use the example of finding the distance between the point A, 1, 2, and the point B, 9, 6. We will start by drawing a quick diagram. So we can see point A is down here at 1, 2, and B is over here at 9 and 6. The length I'm trying to calculate is this length along here. To do so, I need to make a right-angled triangle. I can make a right-angled triangle here, or I can make it up here. I've decided to go up this way. I need to know the lengths of each of these sides. So from 2 to 6, that's a distance of 4 units. And from 1 to 9, that's a distance of 8 units. Pythagoras' theorem says that C squared, which is this side, is equal to A squared, which can be this side, and B squared, which is this side. As long as we have C as the longest side, it doesn't matter which ones we have as A and B. They can swap around. So A is 8, so 8 squared, plus 4 squared, which is B. We can then use our calculator. 8 squared is 64, and 4 squared is 16. Adding these two numbers together gives us C squared equals 80. Now, I'm not trying to find C squared. I need to find out what C is. So I need to find the square root of 80. If we stop there, that's called the exact value. But I can go further and I can use my calculator and get an approximation, in this case to 1 decimal place. So the length of C is 8.9 units to 1 decimal place. That's the algebraic method, and it requires following this setting out with different numbers for our two sides. The visual and numerical approach requires a good diagram, requires knowing which side we're trying to find. We still need to find a right-angled triangle, so I've gone in the same direction this time, and I need to know the lengths of each of these sides. This still goes from 2 to 6, so this is still 4 units. And this starts at 1 and goes across to x equals 9. So from 1 to 9, that's 8 units. Now what I do this time is to show 4 squared, I look at the square that comes off here. So this square has side length of 4 and 4, and its area is 4 squared, or 4 times 4, which is 16. I now do the same for this side. Create a square. That's 8 times 8, so the area of that is 64. Pythagoras' theorem tells me that 16 plus 64 should equal the area of this square. 16 plus 64 is equal to 80. Now, in order for me to find this length, all I have to do now is to find the square root of 80. I can put that in my calculator to get a decimal approximation, and I get 8.9 units. Both ways are perfectly fine ways. One requires more algebra. This one requires a bit of a picture, a bit of a diagram, and some numbers.